Okay, today we're going to be talking about the factor theorem, which allows you to say yes or no whether a factor is a factor of a polynomial. Before we get to that, let's do some refreshers on synthetic division. So it says, what's the remainder when given a polynomial is divided by x minus 2? So the big thing here, when we do synthetic division, we need to make sure we change the sign on this value since it's given as a factor, not an actual x value. So we're going to change the sign so it becomes positive 2. We're going to set up our L. And again, remember your teacher might set up the L a little bit differently, but it all means the same thing. And now we need to make sure that we can keep those placeholders. So we've got 3 as our first coefficient. We have 0x cubes. Then we have negative 2x squared, 5, negative 10. All right, I'm going to run through the synthetic division pretty quick. So we bring down that first number. We multiply 3 times 2, which gives us 6. Anything in the L is added, so 0 plus 6. Next, we multiply. 2 times 6 is 12. We add, multiply, add, multiply, add, and that very last number is our remainder. So the remainder here is 40. Okay, versus question 2 asks us to find g of 2 using synthetic substitution. So on this one, you don't have to change the sign. Notice how this is given as x minus 2, so you change the sign. This we gave you just an actual value. So let's try this one. We place the value of 2 on the outside. Don't forget about those placeholders. So we have 1x to the 6, 0x to the 5th, so we need to add in that 0, negative 4, 0x cubed, so we need to add in the 0, 3, oh, there's 0x here, and then a 2. Okay. You could have also substituted in that value 2 in for your x's into your equation. All right, bring down that first number, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, and finally we add. Okay, so we get a remainder of 14. That very last number is 14. And when it says, what does our answer represent? Well, let's think about that. We substituted in this value of 2, or we did synthetic division in our case, but this value is our input. That's our x. So the remainder, our answer represents the y value. It's our output. Kind of cool. And we're going to see how that comes into play for the factor theorem. So, how can we use division to determine if something is a factor of a polynomial? All right, if, stop and pause and definitely make sure you write this down. If the remainder is 0, then the factor, then it is a factor of the polynomial. Okay, so we are looking for a remainder of 0, and then yes, that factor is a factor of the polynomial. So let's do some examples. And if you want to pause and put this in your spiral as well, because if the remainder is 0, that tells us that the y value is 0 and it divides evenly. It is a factor. So this is the reasoning why. Definitely want to make sure you got this in your notebook, or as long as you've got this slide, you're good. All right. So it says determine if the given polynomials are a factor of f of x. So we've got our factor, and now we're going to do synthetic division to see if our remainder is 0. All right, do we have to change the sign? We sure do. So it becomes a positive 5. We do our L. Let's check for those placeholders. Looks like we're good here. So we've got 1 as our coefficient, -3, 7, -60, -120. Okay, we bring down that first number, which is 1. We multiply 1 times 5. We add, which gives us 2. We multiply. We add. 17 times 5 is 85. 85 minus 60 is 25. 25 times 5 is 125. We add those together and we end up with 5 as our remainder. So is this a factor? No. X minus 5 is not a factor. So that's the reasoning why. All right, let's do one more. Okay, now I gave you 2 factors. So it's the same process, you're just gonna do it twice separately. Okay, so let's take a look at this. Doesn't matter which one you start with because you have to do both of them. So let's change the sign on both. This becomes -2. This becomes 1. Okay, check for those placeholders. Again, looks like we're good on those coefficients. So 1, 1, -7, -1, and 6. Bring down that first number. Multiply, add, multiply, add, multiply, add, multiply, add. Okay, so is x plus 2 a factor? No, because our remainder is not 0. So x minus 2 is not a factor. But let's check x minus 1. So we change the sign, same coefficients as before. Bring down that first number, multiply, add, multiply, add, multiply, add, multiply. Whoop whoop. Yes. So x minus 1 is a factor.